Hello, everybody. Welcome to Handmade Hero, show where we code a complete game live on stream. For those of you who didn't stick around past the end of the recording yesterday, one of our viewers, who I don't really remember if they'd asked a question before or not, it's Benjamin on the chat, uh, actually was like, hey, do you think that the bug was related to not having the bitmap loaded yet? And I was like, I do think that the bug could be very related to that. And we quickly looked, and it totally is. So the bug we were looking for yesterday, we think we know what it is. I didn't want to fix it because I don't ever like to do anything off stream. So basically, we just looked to see if it was probably the case, and it almost certainly is. So what I'd like to do is just take a quick second to show what the bug actually, what we thought it was, and then we can go ahead and fix it. Since we don't really have a way to repro it exactly, we could force it to repro, but since we don't have a way to really know exactly what bug we were seeing last time, we can't guarantee that this is it, but it seems very likely. So if you look at what was happening here, we do have this run through of these piece indexes for every entity, and for each one we store a pointer to the bitmap that was responsible for that piece index, so whichever one we ended up drawing. The problem that we ended up with is that pointer, that bitmap info pointer here that we're getting, that actually only gets set inside the this particular part of the routine, right? So you can see that happening right here. This is where that array gets filled out. And the problem is that we don't descend into this part of the code unless the texture handle we get back is actually valid. That's a huge problem for us because that means we don't store this piece of information back. Now, there's no reason that we can't do that, and we should, right? In other words, this storage here, there's no reason it can't be done here, because this get bitmap info, that will work whether or not the bitmap is loaded. So if instead we were to just say, oh, like, do this, right? Get the thing always and write it back always, and then if you have a texture handle, by all means, go to town, that's fine, right? But what we don't want to do is not actually process this piece of information here, right? Now, instead of doing that exactly, what I'd like to do, I think, is just move this this piece of information, this check, down closer to the rendering process, because the texture handle actually isn't used for anything. And so what I'd rather do is say, look, all of this stuff should really just still happen. And why don't we just save this part, right, where we're actually looking at the texture handle here? Why don't we only defer the rendering if we can't get the texture handle? Because all of this stuff is about constructing the world properly, right? And we'd like to be able to do that. Now, one of the problems is world dim from world height. This takes the texture handle here. And that's the only thing I think that takes the texture handle. But I'm pretty sure, I mean, I could be wrong, but I'm pretty sure this texture width and height thing here, there's really no reason to actually do this way, because that piece of information actually is in the bitmap info as well, right? So if you were to look at, how we're storing our bitmaps, you can see here that we have the dimension information, both the original size that the thing was in, like, when we imported it, so before we like process it and scale it, and afterwards when we store it. Both of those pieces of information are actually available. Right? So I'm pretty sure that there's really no need for that texture handle at all. This texture handle could instead be replaced with the HHA bitmap pointer, and that bitmap pointer would give us everything we need. So I'm going to argue that's what we should do because, again, this is kind of part of my process. I tend to do this just in general. I like to separate streaming information from non-streaming information pretty rigorously if I can, and say, look, when a game starts up, it should have all of its functional information just loaded if it can. And nowadays, it's pretty rare for it to be the case that you can't do that. You're usually talking about something like 256 megabytes, even for a giant system, for all of the metadata you might need. And so all the like 30 gigabytes of extra data that you need is all textures and vertex buffers and stuff. That stuff is all the streaming stuff. Just stream that part in. But leave all of the connective tissue always resident. Why? Because the game can keep running without it, right? Without that streaming stuff. If it has all the metadata, it can always make the gameplay happen every frame exactly as it should. And you can just do worse rendering or, something just flickers and doesn't quite appear correctly or something if your streaming can't keep up, but the game doesn't stutter to a halt, right? And so I prefer to have it so that anything that the game needs to actually make decisions about where stuff is or how it's doing what it's doing, I try to have that stuff resident pretty much guaranteed. And then usually all the stuff that's streaming, you can break that down into stuff that doesn't ever need to be looked at for decision making, right? Most of the time. Not all the time, but a lot of the time you can. And that's just because there's a huge disparity in size between the sorts of things that are used for visuals and the sorts of things that are used for gameplay. Just usually, right? Okay. So in here where we do world dim from world height, what I want to do is just do, maybe you pass me a bitmap info. Oh, that's actually an bitmap. And what we want to do there is be able to grab that out. And like I said, this is producing the change in sort of size. So the only thing we really need here is the aspect ratio. And so that's what the original dimensions will tell us. It's telling us the aspect ratio of the original image. So the original dimension, 1 is the height, right? And here we have info origdim 1. And the origdim 0 is going to be the width, right? And so if I redo world dim from world height that way and say here is the new function definition for this thing, that in theory should get me out of the business of using that texture handle, right? So now in here where we were passing the texture handle before, we should be able to pass the bitmap info instead. And that's all we would need, I think. Okay. So if that's actually the case, now my argument is that we have potentially eliminated the bug that we were seeing yesterday. And in theory, we shouldn't have changed anything else. That's just in theory, though. We don't actually know. Now, that allows us to maybe, potentially, possibly, hopefully, and I guess we'll see in a second, get back to what we were trying to do before. And if you remember, what we were trying to do before was get this stuff working, where we are going to use the information about where our sprites are to try and do some improved snapping of points to points, right? And we talked about that yesterday. So if you're not familiar with what we're doing, you want to watch at least the beginning of yesterday's stream where I talk about what we want to do for alignment, if that makes sense. So what I'd like to do now is just take a look at when we're doing these sprite values for upright, and we pull in, whatever we're doing for our sprite here. We know that this is centered about 0, 0 right now. So the min p is telling us where we would place this thing if we wanted 0, 0 to be if we wanted 0, 0 to be the alignment point, right? So that's what min p is basically telling us. And then we also, at the same time, because we have gotten the parent piece here, we've got this initial p, this right here. this initial P tells us the point that we're trying to align with. And this one will be, that's just accurate in world space. It's just where we want to snap to, right? So what we want to do now is figure out how to compute a location for this new sprite that will match the location that we're supposed to be matching when viewed dead on from the camera. And you can, like I said, go back to yesterday's stream for an explanation of what I mean by that. But essentially what I'm talking about is if we were to look at when we start to set these points now, if I open up the point editor here, right, you can see me tweaking like where this alignment thing is. Let me turn off this that head attachment there. So if you look at where this, let's zoom on in there. There we go. So if you look at how these points are distributed, right, you can see me moving it around here. What we want to do is say, all right, that white point, when we draw, the white point we're drawing there is the point that's being input by the game and saying this is the point you're supposed to align to, right? These colors down here tell us what the points are that we're looking at. So the red point is 0.0, the green point is 0.1 for us to see. And so what we want to do is make something that snaps this red alignment point here to this white point here. That's what we want to do. And like I said, we want to do that such that if I were looking at from this camera angle exactly, and you were right in the middle of the view looking right down at it, it would snap. Now it's crucial to understand that I mean only that particular alignment of the camera and the entity should we get the snapping. And like I said, go back to yesterday's stream if you want to know why in more detail. But the idea here is I want there to be perspective shift as the things move across or up and down on the screen. So I do not want this algorithm to correct for the perspective shift that happens around by resnapping. So I'm intentionally, we need our algorithm for aligning these points to intentionally only align them from one specific camera angle and one specific camera angle only. That is where they should appear aligned. And then anything off of that camera angle, they should become progressively more unaligned as the perspective shift pulls them apart, okay? So that's at least what we're trying now. That's our goal right now, to see if we can make that happen a little more specifically, just without any additional, we want very specifically to make sure that we're not correcting too much and preventing ourselves from getting that nice perspective shift that I want, right? Okay. So let's see now. If I go over here and look at how this is actually being aligned, the game's still running over here, by the way. I haven't turned it off or anything, but so if we take a look at how these sprite values are coming in, I'm going to want to work out a diagram, so I'll probably flip over to Milton in a second. But if you look at how these are working, we get this back, and what we want to do is take the sprite min-p that we received, and we want to adjust it for the alignment. So the entire goal of this process is to adjust that sprite min-p. Now, there is something a little confusing about what we're doing, and I'm not sure exactly how we're supposed to deal with it. It's a little bit underspecified, right? And the part that I'm talking about is this piece offset here. So there's two choices that we have, and they're both probably wrong, and that's why I say we might need to like upgrade the way that we're processing that. But the piece offset right now is used for two separate things. One thing, it's used for offsetting something in space. So, for example, if we're saying that the head attaches to the body and we want the head to be like up higher than the body in Z, right? It's being used to do that. But then it's also being used to do something totally separate, which is to provide secondary animation to the head as it bounces around, right? And so our problem is I don't really know exactly how that should be working with respect to the alignment. What I'm going to say, because it doesn't really matter, but what I'm going to say at the start is, let's say that the piece offset is added after alignment. So you align these 2 points and then you offset the piece from that alignment to its location. So offset can just break all the rules. It can do anything it wants. So the alignment happens first, then the offset happens, right? So I think that's what we want to do. The reason I think that's what we want to do is because really alignment is just for our own art aesthetic purposes. And so I think it's sufficient to do it this way, where we just align a point and then say what kind of displacement we want off of the point. I can't think of a reason why we can't just do it that way, although there might be some reasons, I'm not sure, that we don't want to do that. The reason that I don't think it matters is because let's suppose that we then find that that's not sufficient, and what we would rather do is split into 2 halves. One half is there's the offset of this piece, and we want to do that before aligning, right? And then the other one is secondary animation that moves it around, and obviously we want to do that after alignment. It's trivial for us to just split them, right? Because we can always, just before we start processing min-p, we can always stuff the pre-alignment offset in there, do the alignment exactly however we solved it, do it, and then apply the post-alignment. So we can, it's free for us to split this later and shove one part of it in earlier in the process if we need to. So I'm going to say right now, let's just not worry about that. We'll let this happen at the end of the process. And then we'll, like later on, right, we can decide whether we need to change up how that's working. So at the moment, what we can see is this is the part we then have to work with. This right here is sort of the stuff we were doing that we found worked well for sorting, which is to say using the Y displacement. And this is us preventing it from sinking down into the floor and stuff. This is the part that we now want to look at more closely. And we need to figure out how we will compute these values. Now, hopefully this won't be very complicated. Hopefully this is a relatively simple piece of math for us to do. But we have to think about what it actually should do first, so we don't actually know if it's simple or not. We're about to find out after we sort of state what our requirements for this particular thing are. So here's day 522, and this is a line for default camera. Okay. So what we want to do, like I said, let's take a look at a side view since it's easiest to understand what's going on. In that case, I think, let's draw the canonical wall plus floor, right? So this is wall. This right here is floor. Not flower. Flower? All right. It's flour apparently. So it's like a, it's a little like sack of flour. And it like poofs. All right. It's great. Let's bake a biscuit. I'm chuffed to bits. Really, I didn't think I would make it past cake week, but I'm just chuffed to bits. All right, so anyway, here we are in a line for default camera, and what I mean by that is there is some default camera that's pointing right down here, like I said. We're looking at this from the side. Here's a wall, here's the flower, and what we want to do is create a sprite here that's going to have the alignment information that I want. Now we know for the first, just to start with, is it's going to be something like the center point of the floor. What I'm going to do is I'm going to, I need, right, if I were to draw a line through that point to the camera. So I don't know exactly how, the camera's actually pointing pretty downward, right? So I do think it's something like this. But if I were to draw a line down through that point like that, there we go. So what we're talking about with a line point is we know we have a sprite now that's got some point on it that we computed as the align point, right? And what we're saying is we want this point to appear in the same location as that point, right? So we're trying to figure out where to place this sprite so that this point and that point are on the same line with the camera. Now, what we were doing before, and this is why things were sinking into the ground, before we started down the path of let's figure out how to do the correct placement. So before yesterday, or before before last Sunday. We were just snapping these points together in world space, right? Like that or something. And that's not going to cut it because that's going to sink right into the floor, right? So what we want to do instead is figure out where can we place this thing so that it will properly look like we did that, but not sink into the floor. So what we want to do is say, okay, I want to figure out the location of this point such that the lowest point on the thing, wherever that was, right? I want the lowest point to stay constrained to this plane, but I want this point to end up on this line, right? So it's free for us to do one of those things, right? One of those things takes almost no thought at all. We know what the lowest point on this sprite would be, right? Because literally we just have an x and y axis and we're going to draw it off of that. Wherever we place the thing, that's the lowest point. It can't go lower than that, right? Now, rotation is going to change this, so again, like I said, we're going to have to go through this as a second pass. Hopefully, if we get through with this today, we'll start on that second pass right after to make sure that we do some slightly different stuff for rotation, because it's a little bit more complicated. But again, take rotation out of the equation for a second. We would know what the lowest point is. It's just where we were going to draw it in the first place, right? So that is free to just say, look, wherever this thing would have been, whatever this alignment point was, we just make sure that that z is the same, right? And then we know that's how high it is. So that's really pretty basic. To move this down to here, that's fine. So the only real question we have to ask ourselves is if we were to slide along the z-plane, right? And we don't have to slide in x because x just works, right? X, setting the alignment point in x, matching the two alignment points in x will just work because there is no need to play with the z-bias there, right? Y is the only thing that affects our z-bias. X doesn't because it's lateral on the screen, doesn't change the depth at all. So if we're going to slide, again, and this is in the y-axis, right? Because remember, z is going up here. So if we're going to slide in the y-axis, here's our camera again, right? And let me draw that line coming down. So here's that. Let's say that's our line. Here's our alignment point. You know, here's the camera. And we want that to line up, right? So if we were to say, all right, let's place this thing on the ground, right? And we know we've got a point somewhere on this thing that we're going to align. All we need to know is what would be the point that we would place it at, so this, if we were to make sure that this was on this line, right? So we want to slide this thing such that it ends up looking like that. We want to know this point, the thing that would place it such that the alignment point will be in the same line as the alignment point that we're matching, right? The child point and the parent point. This is the child point. This is the parent point. We need those to appear in a line, right? And that's all, right? Pretty straightforward. Okay. So there's a number of different ways that we could imagine solving this, and they kind of correspond to two ways of looking at this diagram. One way of solving this would be to say, well, we know this line because we're saying that our default camera, if this thing were placed in the center of the screen, the default camera pointing up, it's actually, this is just, you know, that's just the z-axis, right? That's just the z-axis of the camera. That's what that is that you're pointing down. So we know what this line is. We don't have to solve for it. We just have it. It's the z-axis. So one thing we could do is say, look, let's just say that we align the alignment point with this thing. So we're going to construct around the z-axis. How far down the z-axis would we have to push before this hits the plane? Right? The other way to do it would be to say, let's place this at the alignment point and figure out how far we have to slide this way before we hit this line. Now, my intuition tells me, and that intuition is not particularly good, but my intuition suggests to me that pushing along this line is the easier way to do it, probably. But I would guess that probably if you worked either one out, they probably come out to basically the same. Meaning I don't think either one is going to be all that more complex, right? That's just a guess. All right, so let's again recap. If we assume then that we know what this line is, because we know that it's the z coordinate of this alignment point, so we don't really have to do much to that, right? So if what we want to know is moving along this z-axis, where would we have to put this thing such that this was correctly at the horizon, at that line? Well, it really shouldn't be very difficult, because we know this length, right? We know how high up we actually need this thing to go, right? Because this point and this point we already computed. So if we subtract their z's, we get like a height value that's like how high this thing needs to go, right? We also know this camera z-axis, right? That's the camera z-axis. So we know its ratio of movement to its unit, right? We know its unit length this way. We know this, right? By it's just a dot product with the world z-axis. And that just gives us, here's the z-axis here. Here's the camera z-axis. Camera z dot actual z-axis, right? Gives us this. And hey, when you dot something with the z-axis, that's like saying cx times zx plus cy times zy plus cz times z. Don't ask me why that came out of z. Right? What do we know about the z-axis? Its x is 0, its y is 0, and its z is 1. So that is the value, right? So we actually know that the z coordinate of the camera z-axis is this amount, right? And we know this amount. So if we want to push this thing up until it would be at the height where its low point, right, would touch the ground there, not particularly difficult, just h over cz, done, right? So h over cz is the amount, we could call that t, let's say, is the amount along this axis that I would have to push in order, again, along the camera z-axis, to push this thing from the alignment point to get it to where it needs to be. And so at that point, we're just looking at literally this. T times that camera axis, the alignment point, we start here. Alignment point plus c gets us right there, and we're done. Right? So I think this displacement is really all we needed. It's incredibly simple to compute. I didn't even have to solve for anything. It was literally just inspecting the diagram was sufficient to give me basically how I would make it. I don't see a lot of problems with that. It seems relatively stable. And like I said before, it allows us, we could do whatever we wanted there. If we want to include some kind of a pre-displacement that would move this whole thing off of the alignment point first, we certainly can, right? Because this term right here can have anything you want baked into it. So, you can have alignment point plus t times c plus offset, right? And these things can do whatever they want in that regard, right? And so the only thing you have to do is figure out how you want to compute h, whether you want it off of the original or off of the displaced, right? And that's the only thing that would change how this thing would look, is that computation of t, right? So we should be able to fuss with this however we want. And it just doesn't seem like it's going to be that big of a deal. You know, famous last words, but I'm fairly comfortable with that. So when the sprite values for upright things come back, let's just take a minute to assess what, and I'm going to move it over here so my head's not in the way of part of it. Let's just take a minute to assess, like, what do we actually have there and how does that correspond to the diagram, right? Well, this initial P, okay, that's good. This initial P here, I don't know why I keep going, there we go. I was trying to highlight that for you, but the wiggle went too far and it went over there. This initial P, right, that's that alignment point of the parent, so that's where we were starting. That was this, right? So that's where we want to move out from. Then we've got the child point here. We need that to find this, where the alignment point is supposed to be. We need to find that height, so how high up off of the ground that's going to be. So how do we do that? Well, this sprite values for upright, that's going to give us back a min p that effectively is that height. So this sprite min pz, before we zeroed it here, that sprite min pz was the height of the alignment point, right? Because that was how we computed it. See here? The min p is just, hey, let's step backwards on the x and y, along the x and y axis for the sprite, and let's see where we end up if we want to do our alignment, right? So that means that the min pz, right, that z displacement, that's actually the value we want. Now, it's going backwards, right, because so that's the negative, essentially, of the height, because it's going to be going down into the ground rather than up. But it's still the value we want, it's just the negative of the value we want, right? So if we were to first say, what's that h value, right? Well, the h value is just going to be this. So we already know what that is, right? And again, we know that CZ, this is starting to piss me off. Okay, there we go. We know that CZ because, again, it's the camera z-axis, and I believe that's always part of the render group, actually. I could be wrong about that, but I'm pretty sure it is. Well, actually, you can see it here. We're getting that information like this. Right? So here's our camera z, so we can get that trivially. That camera z axis is just grab out the value, right? So that gives us the two things we want, that height and that CZ. Now, what's the degenerate condition here? Because, watch what's going to happen. So that t value I said is h over CZ. That gives us that ratio of push. Well, notice that now we've created a situation where we can get unstable, right? As that CZ approaches 0, this becomes an undefined value, and it will explode, actually, right? It will start getting higher and higher and then go to an undefined value. But looking at this, right, as you can see how it's constructed, the math usually doesn't introduce synthetic things. Those are usually real things that you're seeing. So what is the real thing that we're seeing here? Well, if you come back to the diagram, we're asking this to push this thing up, right, to account for this much height so that we don't interpenetrate the ground, right? Well, if the camera was all the way down here looking sideways, right, then it would have to push along this line, and there is no elevation. So it could push along this line for infinitely long and never get any higher, right? Make sense? So that is, the math is telling us there's a degenerate case, and that's exactly correct, right? Now that degenerate case is fine because our camera can't go down there, right? We don't let the camera do that. But that's exactly what that's telling us, right? And we can go ahead and make sure that we sort of account for this, right? We can say, look, we don't even want you to entertain any situations that are even close to this, right? Where is the actual? There it is. So we can say, look, if the camera is not in a reasonable position, then we're not going to go any further down this, right? So the Z has to be, it has to be kind of looking down like this, right? And we don't allow the user to move the camera at all. But our cutscene stuff may, cutscene's the wrong word, but our camera movement stuff that focuses on things in the level or whatever, it may do some flexing. So we don't want to hard code it. We still do want to look at this value because we may allow it to vary. We just don't ever want it to get particularly low. So it should stay, up in that range where this value is going to be, I mean, that's probably even reasonable, but, All right, so, maybe I'll even leave it there just to be a real grouse about it. So we want to make sure you're fairly elevated because that's the only way we really allow this stuff to line up. And then we say, okay, let's make sure that everything else falls into line, assuming that that's the case. This is the t-value that we know that we actually needed. That t-value is the thing that we would have to displace to get these things to line up properly. And so now I think we can actually just apply that alignment and be done, I think. So meaning if now I said, look, forget about this stuff that was happening before. What we're going to do instead is just apply the camera z-axis on this proportion. We're going to pull that to let it pull out by that amount. And then we're going to apply whatever the displacement is, right? Now, I'm going to nerf that for now. Oh, no, that's correct. Sorry. This is the displacement, right? So we're just going to take whatever the initial P was. That's the alignment point. And we're going to take that T camera Z, and that's going to be the min P. We're going to offset by that much, and that should push us out. I think that's correct, although actually that is actually correct. Right? We want to set the point to be exactly there. So we don't want to add. We want to actually make that work. Right? Is that right? No, that's not right. This was aligned around 0, 0. So we still need to include that offset for our alignment point. So I believe this is correct, right? Yeah. So then we would apply this piece offset. I'm just not going to do that yet, right? I don't actually want that to happen yet. So I'm going to compile this code and see if this, without the offset, how we're doing here, right? Maybe really terrible. We'll see. So let me take a look. What the, ooh. Why is there a second? Is that a bug in our, wait a second. Is that a bug in our art pipeline that got added? Let me delete that. I'm curious if we have a bug, because we never, we still have to do a bunch of debugging in the art pipeline stuff, and I'm just curious if it adds points unnecessarily there. Yeah, so I'm not sure where that came from. So anyway, here's the base of next. So, well, you know what, we can start by looking at the alignment of this. So here's the motion of this around, and you'll notice I'm getting really good behavior. There's nothing, it's not interpenetrating the ground at all, right? If I leave it in a particular place and then switch to the debug camera so that we can kind of look in here at those points, that is just right on the money. Look at that. I mean, that's just great, right? So now if I go back here and say, let's turn back on the alignment for this guy, for example. So here's that alignment point that I'm just moving around on me. Then I'll look at the head, right? Let me add one of these here, right? And then we'll sort of shift it around. Okay. So you can look, and that's just locked exactly too, right? So that seems like resounding success to me. I mean, that just seems great, right? Yeah, I got no complaints there. So I think that's really all we needed. I think that's very good. So our only real issue now is what to do about the rotation. Now, we have another decision we can make that's free. So we'll go do rotation now. But we have another decision here that's effectively free for us, and I just don't know which way we want to make it. But effectively what we need to know is when we apply this offset, when do we want it applied? Right? So let's suppose that I apply it now. So it just gets added after the fact. What that means is our alignment points will no longer line up because we lined them up and then we moved the thing, right? So that offset is not taken into account by the alignment. So if we look at how these things are displaced now, whatever that piece offset is, and again, that piece offset, like I said, is kind of important because I want to, be able to have that secondary motion in there, right? But that piece offset then means that if I look at the alignment points here, in theory, any amount of alignment that may have happened there would make it so that these would not line up anymore. I'm moving the head around here and looking at that green alignment point, and then looking back at one of these. There we go, snap on there. I don't actually see it drawing the red point anywhere. Is there a reason for that? Oh, do I have to be in debug camera mode for that? I guess I do. I don't know why. Oh, it might have been clipped. No, I don't know why. Oh, well, maybe. No, you know what? I have no idea why. All right, so anyway, there's that red point, and there's the green point. Do you see how they're not aligned anymore, right? Before, they were exact. And I think we could probably even make that a little bit clearer, right? If I actually compile that down, right? There we go. So right now, those are exact. If I swap back and forth, right? They're exactly aligned to each other. And if I put this on, assuming that there is an offset, which I guess I don't know, they won't be exact anymore, or they shouldn't be anyway, right? So if I go back to alignment points here, I have no idea why that doesn't. Oh, because the entity's not selected. Okay. We got to do some cleanup on our UI for this editor. It's annoying. All right. So you actually can see, yes, there is a displacement, right? It moves a little bit. Not much, but a little bit. And it's whatever that piece offset amount is, right? I'm going to go ahead and say that I guess we don't really care. It looks fine with it just getting added in. I mean, it was barely a difference anyway, even for the amount that we were using right now. So maybe that's just fine. I want to go into like add player. I want to see how much displacement actually is there. If we look at adding the headpiece on here, you can see that headpiece being added right here. It doesn't really look like there's very much Z there. And maybe there should be more, right? Because there maybe should be more exaggeration to the separation between the two things. So one of the problems, I guess, that we would have is we don't really know what kind of stacking we want there. I don't know. So if you assume that, yeah, if you assume that this is in roughly in meters, you know, maybe this is more, should be more like that. Maybe. Again, kind of hard to say. But, you know, we need to decide on how far up those things should be. But, you know, there's going to be some number. And again, what that number is really going to determine for our purposes is how much perspective shift you get between these two elements, right? And I like that perspective shift. You know, I want that in there. So I think that's all we really needed to do. Looks like we've got really good shape there, and you know, the sorting seems basically perfect now, so everything's happy and fine and dandy. And so really what we want to do, I think, is we'd like to go back in and get some rotating elements in there. So, you know, maybe make the head just spin around for no reason. And then we can go and make sure that our rotation works. The body is doing shearing right now, and we're not getting much of an error from the shearing, but that's because the shearing doesn't really deform the shape as much in terms of where the high Z values are as spinning it all the way around would, right? And so we have to kind of decide what we think should be happening with rotation, and I don't know. So it may be that because we're aligning the alignment points now, which is good because, I mean, they're called alignment points for a reason. Because we're aligning the alignment points, I think what we want to do is say, well, maybe rotation can just be made to work directly with the fact that those are aligned, and maybe it just doesn't matter, right? Because since the alignment points will align anyway, then it doesn't matter what rotation you did, it'll just work. Because we don't care what the base point is anymore. That may actually be true, right? So I think if we look at what happens here, this value is the only value we probably would have to change. Meaning that H value is, if you imagine the thing is spinning around, that H value is not necessarily the point that needs to be pulled out of the ground, right? And so that's really the part that I'm not sure what we want to do with. Yeah. So here's what I'm thinking. I think what we want to do is maybe make this H value directly proportional to the sprite height instead of actually looking at the min PZ. And the reason I say that is because for a sprite that spins around, we're gonna need to keep it a consistent distance from the camera. We don't want it to do this. So it may be that we need to just say, look, based on the alignment point, we're gonna say that we use a particular maximum value, maybe based on whatever the larger of the two fractions is. So if the alignment point was 25%, then we know the most you could sink into the floor was the 75% if you'd spun 180 degrees around with rotation. So we use that as the distance. But it's constant. So we don't care how you've rotated. Because again, as you rotate, we don't want to move you like further. We don't want it to pulse into the camera. Because for perspective, you'll see it, right? If we were orthographic, you wouldn't be able to tell how it was moving relative to camera. But with perspective, you would see it in large. So what I think we want to do is compute a constant value for that, and I think that would do the trick. That seems pretty good to me. What I'd like to do first is just say, look, let's get some rotation in there so we can see. You know, doing this is going to be pointless if we don't have some idea of like what's actually happening. So we need some way to get the entity spinning around. I don't know if we have anything like that at all. It looks like in the T movement stuff, there's some skewing, but there's not. It doesn't look to me like there's any rotation, actually. Where are we getting these x-axis, y-axis from, actually? Entity x-axis, entity y-axis. Where are those getting set, though? I don't actually see anyone modifying them in the movement code. So I guess they're only being set up inside the brains, maybe? Are they just being cold set? Can we do a little... Yeah, who's setting those? I mean, because nobody here is doing anything, right? And nobody here is doing anything. So where's that, what am I missing, folks? We must be setting something, because if you look at what happens to the like, we're definitely warping the axes. I mean, look at that bottom. In fact, you know, if I turn off, let's say in here, I turn off the alignment points for the base of neck, right? So we're just looking at this thing. I mean, look, that's totally setting a skew on the axes. So someone's setting those axes, right? And if it's not in the brain, where is it exactly? Because I would have thought it would have been in here somewhere where we would have set those axes up, or, you know, back in the entity code. But maybe it's using some kind of a, like, convenience function that's not in the place that I was looking. Let's see. It's been a while since we ever looked at this code. It's just kind of some... I like that's a good to do right there. I mean, I'm not seeing us deal with that anywhere in particular, right? Ah, okay. So it is setting the y-axis, it's just not setting the x-axis. My bad. So here it is. Here's us setting that x-axis. I'm sorry, that y-axis. That's what's that head delta, right? That's what's allowing us to kind of do that pointing there. So I don't really know of anybody else who's even touching this stuff. You know, oh well. All right, so if we wanted to make this thing spin around, we probably could do that by, I don't know how exactly we would want to do that. But I could just have the t-bob value or something like that, or a t-spin value that was just spinning this thing around. I don't have a lot of other ideas. But basically all I'm saying is, if instead of setting it this way, we just had the head kind of do this sort of thing. I don't know. The only thing is the head is not really an entity right now. I mean, we sort of have some vestigial remains in there where it is, but it's actually not being processed as a separate entity. That's not something that's actually happening, right? So yeah. I do think that probably we want to fix the way we were doing this, and I just don't know if I want to do it right now. I think I'd rather just hack it in and then move to it a little later. But what I was going to say is, the entity pieces thing, I don't think worked out really well. I don't love it. I think probably what we should do instead is just have the notion that entities snap together. So the head's an entity, the body's an entity, the glove's an entity, and they all snap together, right? I think that's what we should have done, and so I think I will do that as, you know, a separate pass maybe next weekend. I just don't want to do it right now. But anyway, what I'd like to do is say, okay, let's go ahead and see if we can't just hack in something spinning here for no good reason, right? So inside the thing that draws, I'm just gonna hack in like a hard-coded thing to spin stuff around. So inside the entity code, maybe we'll just spin, and I'll say that in here, this entity x-axis, entity y-axis part where we do axes deform, I'm just going to have these things spinning around continuously. So I don't know, like, here's a ridiculous thing. This will just be some angle thing here, and we'll put a DT on it, and we'll just say, like, all right, this is actually right there, let's say. So we just accumulate that over time. In here, instead of these, I'm going to say, all right, x-axis equals right, something like this. So we're just going to produce like these two, and actually, well, can I do this? There we go. So if I just say, look, give me the x-axis that's built off of that angle, and then give me the perpendicular to that, that should be sufficient, I think. So let me see if I run this now. Yeah, you can kind of see everything's just kind of spinning around, right? All right, so first let's talk about the thing that I was saying. You can actually see it happening, right? So what's going on here? Well, if we go to the debug camera, you can actually see the way these things are pulsing in and out of the camera. That's exactly what I was trying to say would happen. Why? It's because that min P point is going up and down and up and down. So it's not the lowest point on the sprite anymore, right? So that displacement really doesn't help give us the information that we want, right? And so what we'd rather do here is say, all right, we need something that's going to be more stable than that, more stable than the min P, right? And I don't know, again, like exactly how we want to compute that value. But what I would say is let's make it part of the sprite values, right? So in here, where we've got like min P and then, some other stuff, this Z bias here, we don't need this, so I'm going to say that is going to become the value, right? So this is going to be Z displacement, and we're going to use that as a value that comes out of here. So we're going to say, not going to use min P, we're going to use Z displacement. And then when we compute these, we're going to actually compute that as a separate value, right? And the way that I want to compute that value in this case is I want to say, look, we want to know maybe without using the X and Y axes here exactly the way that they were being used before. We want to compute some stable value that's representative of the alignment point, maybe. And again, I really don't know what the right way to compute this is. I don't think there is necessarily a right answer. I just want something that's going to be stable so it doesn't change as the thing rotates, and that roughly corresponds to aligning it if you weren't rotating it. So if you weren't rotating it, right, so if you assume that this x-axis and this y-axis were coming in stable, right, then you can see what we would have been doing in that case. This is the value we would want to compute, right? The align py times the y-axis z, right? That's the value we would want. This is not going to be negative anymore because we don't need to do a double negation. We're just going to provide the z displacement that we actually want. And then what we want to do is say, okay, how would we compute this value instead of doing it this way, right? how would we compute this this value for non-rotation? And so if we just use this in this one by itself, that would avoid doing any rotation that was implied here. So what we can do is say, well, this axis would have been this prior to rotation. So if all we want is the z out of it, then that's this. So let's suppose we use that value. That should now give us the same results when we're not rotating and when we are rotating. We displace it the same amount, right? In theory, anyway. Okay, or not. How is that? How is that possible? The world dim y, the y-axis h. Oh, pfft. Okay. Not sure why I did that. It helps if you actually set the value you said you were going to set and not some totally different value that's actually not at all what you wanted. All right. In theory, this should be stable now. And yeah, it is, right? So now as these things spin around, they should just spin around about their alignment point. And so, you know, if I go in here and I access the alignment point of one of these things, you know, like here's the alignment point of the head. If I move it like that, when it rotates, it should rotate about its alignment point, which you can see it doing, right? You can see that, right, that it's rotating about this point. And so wherever that point is on the sprite, that's what it would rotate around. And I think that's what we want. Again, we don't really have much in the way of animation knowledge in the game at the moment. We could have other things like separate alignment and pivot points if we want to. It's very easy, it's just a displacement that happens. But at the moment, we don't really have any reason to believe we would really need that. So I think whatever the alignment point is for the time being is probably fine. If we wanted a separate point that said where we would rotate around, the way we'll do that is we'll just add a point in here, and this will add one of these for pivot, right? And then we can have an alignment and a pivot point that operate separately. Again, don't care about that at all right now, so I think we're fine. So that pretty much concludes what I wanted to do. I think we crushed it. To be completely honest with you, I think we crushed it. That's just fantastic, and everything looks great to me. I'm going to take out that ridiculous rotation nonsense. Because obviously we don't actually want that to be happening. That was just a test. But now we should be able to go set those alignment points and get back to just playing with the art assets a little bit. So if I now wanted to set up the hero properly, and we do have to get an art patch from Anna actually before the hero is actually correct because the head directions were wrong in the art file. In fact, you can kind of see if I create, look, well, let's go through and actually do them all, I suppose. And you can see what I mean. So if I go in here and I select some of this stuff and actually start to set the alignment points. Oh, you know what we could do here too? Let's actually make it so that if one of these is off, it doesn't do the drawing, right? So that that code is here, right? No. I'll be honest with you, I don't remember where this is. Here it is. So this thing here where it's like should draw alignment point, right? So should draw a line point is what would cause these things to be drawn. What I'd like to do is should draw a line point. I want to make it so that we won't descend into this code if should draw a line point for our alignment point is wrong. So for example, this should draw a line point here. I'm going to wrap this like this. and say we need two things. We need like, are we in debug mode? And I don't really know. I don't know if we have that. Do we have that? Does anyone know if we have that? There's should hit test. Let's do that. Kind of crappy. Sorry about that. We should probably improve this stuff a little bit, but we'll get there. So in here where I say, look, if I'm in, edit mode and this alignment point should be drawn or not, let me just go grab whatever the parent align, not the parent align, my alignment point is. What is it? Child align. So child align, child align, child align, child align, this. So this find align here, so that doesn't tell us which one it actually is. But that's okay, because I can obviously figure it out myself. But so the child align that we're drawing, this one, it looks like for some reason we don't actually have a function for getting the index of an alignment point, which we should. You can see here we don't actually ever have a thing for doing that math. And we kind of should, because it actually happens already inside the gen entity. What is it? Entity gen? Yeah. So in here, right, people are doing that nonsense, but we don't actually have a function for it. Like this, right? Well, no, I guess they're not. I take it back. That was doing it on the entity visible pieces, not on the alignment points. Sorry, everyone. Not really. Not the case. So, all right, I won't chastise myself further. I'll simply say that we do want that, and what I want to do is have a thing that's like, get align index, and we'd say like, here's the bitmap info in question, and here's the align point, and it would just do like point minus align points, right? So just want something that's going to give me back that index, because we need to know what it actually is in this case. So we need to say, look, for the alignments on this guy, like, yeah, are we supposed to draw that or not? And that's just my way of like hacking in. Well, I'll show you what it's my way of hacking in, but what is the problem there? Oh, that's thwarted again. So the problem is, this doesn't return the p index, and what you can see here is it's because this will go ahead and do like a synthetic one for you if it couldn't find it. So I really have two choices here, but this shenanigans isn't going to work. So if we have, this, then I could do this. I guess that's what I'll do. It's not my favorite solution, but it's good enough for now. And probably for always as well. So in this case, we would say, all right, the point is this, the index is this. In this case, we would say, oh, the index remains 0, and we're going to do that. We could set the index to some kind of like not found value. you know, something like don't know how I feel about that, but we certainly could. So at that point, what we would actually do is say, oh, child align dot index now is like a thing that we do. And then the people up here who are doing child align, this is actually going to be a find align result, and it will take with it that piece of information. So then we would be looking at something like that when you actually use something out of the child align as you kind of flow through the process there, right? That seems fine. Anyway, oops, shoot, there we go. What else we got? This one we don't need to remember, so this can just do that, and it doesn't matter. I don't know what else we got. Yeah. So at that point, I think we should be able to successfully turn things on and off, maybe, or I broke everything and it's horrible, right? So in here, we've got this stuff in here. I'm going to add to parent attachment, and then it shows up. If I turn it off, it goes away, like so. So the problem there, all right, this is not as good as I thought. We're still a little screwed. So the problem there is actually I want to do it on the parent. So actually, this was a lie, by the way. It's actually the parent align that I want to mask out, right? So I actually want to do should draw a line point parent align dot index, right? That's actually what I'm supposed to be turning off. So yeah. I also probably only want to do this if this is the entity I'm actually looking at. And I'll be honest, I'm not sure how that was happening, right? Is that part of the hit test function? So I'm not sure how it was, because it's this dev ID here, right? That's telling you that piece of information. I don't know how we were doing that magic sauce. I just don't remember. To make it so that should draw a line point on the hit test was only telling you to draw stuff if you were selected. Like, I don't know how we were doing that. If highlighted, should be here. It's that. All right, so this is actually what we want to do. That's better. So if we're not highlighted, we always draw. If we are, and let me just double check that that's for the whole. That's for only this piece. And that's not good either, really. Because we need to check to see whether our parent align point was turned off of people downstream for us. Ugh. So we kind of need to do something like this. To say, look, something in this stack was highlighted, so that's good enough for doing this checking, right? I guess that's what we would want to do. And we also would have to do something where we record that the fact that we were attached to the highlighted person. Gosh, if we really want to do this right, it's pretty complicated. It's actually this. Right? And this is going to get worse too, because the entity itself is actually in the future we would be looking up into an entity potentially to do the snapping. So we'd actually need to look into the entity and say, was that entity highlighted? And if it was, we need to turn this thing off. This is a rough feature. I have a better idea. I think. I'm going to claim this is a better idea. I'm going to do all that. It's gone. It's over. Forget it. Never happened. It's gone. Goodbye. You didn't see it. We're going to erase this part of the video so that no one will ever know. Right? All of it gone. Goodbye. Okay. So all that's gone. Here's what we're going to do. In the editor, where we actually have this edit stuff happening, and we've got those alignment point buttons or whatever, right? Like this nonsense here. Like this kind of crap, right? So this stuff, where we're editing the alignment points, I'm going to have a thing that's actually just a button, right? And inside the editor, we've got, a button thing that's like draw a line point, right? Here, this thing. I'm going to have a, like, draw children or something. Or like, yeah, I don't know. We're going to have a draw children button. And then what I'm going to do is inside the alignment point thing, I don't know if I need to be in a section here. I guess I do. Probably. Not sure how this stuff works really. All right, so in this section stuff, it looks like, yeah, like right here, I can just do a button, like an editable Boolean, right? Like this. And so I can just say, look, give me a Boolean. It's a pointer to the draw children thing in the editor. So that's what I'm editing. That show children button is gonna like tell, okay, is gonna let you toggle this. And in here, we can have a thing where you can say, like, yeah, the should hit test thing and the should draw a line point and all that nonsense. So this stuff, we can just have another one of those that's like wherever the should draw children or should draw a line point part was, we're going to put one of those for should draw children. And that's going to do, in the hit test, we're going to have draw children set there, and that's what it's going to return. Now, at the outset, when we init this stuff, I assume there is an initialized editor, yeah. We're going to set that to true, because obviously we want to draw children by default. So then, inside the entity, what we can do, here's my huge genius idea, it's really smart, and you're going to love it. So when we actually go to get the bitmap info for the parents here, the parent bitmap info is used for that alignment. I'm going to go ahead and say that we have some kind of a thing that's just like, if you didn't get that, or yeah, like if that was set to 0, then it just undoes it or something. Or we set something in like the array that says whether it should be drawn, right? Like this. You know what I'm saying? So we could just say, like, look, are we supposed to draw children of this thing that we're looking at right now or not? And then we'll just remember that setting for whoever it was. You know what I mean? And I guess I don't actually know... Oh, I could even do this a little bit better. If we did it this way, dev ID from U32S or whatever, right? So I just did this and said, okay, what's the dev ID of my parent? Because it's that, right? So if that's the parent, I could just say, oh, it's visible if like should draw children, excuse me, for this parent dev ID is true, right? That's even better. Yeah, that's even better. So then what I'd say is, okay, there's a should draw children thing on for that guy or not, right? Whatever. And so we pass the hit test down and we say, look, tell us the visible thing for this. If we end up saying that that it's not visible, we just won't draw it. Then this draw children is not that. It's hide children for dev ID, right? And then what I do is say, okay, hide children for dev ID is just 0 by default, so we don't hide. In fact, that's probably just fine. Like, is there a null dev ID? I don't know if there is. Excuse me. I don't even know if I have to do anything for that. So instead of having that, we actually have a dev ID here. And we have a dev ID that's like, you know, hide children for dev ID or something like that. Well, actually, no, you know what? I'm taking it back. Let's leave it this way. Right? And so all I guess we really need to do is here in should draw children, you pass the dev ID of the parent ID, right? And then inside should draw children, we just say the result is should you draw the children, or the hit test editor highlight ID is not equal to whatever this was. So you're giving me the person to check, and I say, if we're just supposed to draw children anyway, then it don't matter. But if we're not supposed to draw children, is this the person we're highlighting, right? That parent. And if they are, then don't. Now, I think I have to do an R equal there, because that's a... there's no overlayer operator to that. So I think we just do an R equal and say, look, if these two things are not equal, then we're good to go. I think that's what we want. Let's see what else we got here. Dev ID from pointer, draw children connected from ability to avoid star. That's a good point. I agree with that point. I think that's it. So now if I draw, in theory anyway, and this is only a theory, I at least have some slightly better human factors on that particular part of it. Whereas if you're editing the alignment points in this thing now, and you've got you're looking at something and you're like, I can't see anything. In theory, we should be able to get this switch to work. Now, why? That was a little weird. So it started off negative. but I'm not sure why. Did I screw something up there? Because it should have started off positive, right? Oh, did I delete that? I probably deleted it. Sorry. Let me refix that. There we go. So yeah, all right. So I think this is now correct. It took me a little while to figure out what the best way to do that would be. I think this is the best way. Or at least it's a good way. So we set the piece equal to visible. We then say, look, if the parent thing that I was supposed to be talking about here, if that thing should draw its children, then I'm visible. Otherwise, I'm not. If I don't have a parent, then I'm just always visible, right? I don't have to worry about it. If it's visible, I push the sprite. If it's not, I don't. That's pretty straightforward. And so now all we have to do is focus on answering this question properly from there out. So then we say, okay, who am I highlighting, right? So should draw a line point, right? Sorry, should draw children. I think it's who I'm highlighting, or is it who I'm selecting? So I'm not sure which one of these is the one that I actually want. It could be this stuff too, right? Like, I don't know. So let me go remember quickly. Well, remember is the wrong word. Let me go look up who we're actually showing in the editor. And that's the person that we actually want to use. So here's that part of the editor. And if we're doing a bitmap here, we do get assets asset index here. Excuse me. So that actually gets us back a particular asset. Unfortunately, that doesn't really give us... Ooh, that's a little harder. That doesn't really give us what we would need to know for whether or not we would draw children to that particular dude. Right? Because... that's just keeping the asset. It's not really saying which dev ID was captured there, right? So this active asset index, let me see where that's... But it looks like the highlight ID is set to that. So it does look like this is true, right? So should draw children is saying if you should draw children or these two are not equal, then you're okay. That seems correct to me. Now, of course, it didn't look like it worked, so I guess it's not correct. So now we have to find out why. But I do think that's fine for the way we're doing the editing there. Should just work. All right, so let's see. If I'm selecting this, I don't know what I'm selecting here actually, but all right, so I'm selecting something. I can kind of see what the problem probably is there, right? I'm selecting an entity, but who knows which piece I was clicking on, right? Like that will not change. This is just changing the asset index I'm looking at, but it's not going to change. Yeah. So I think I can probably still do this, but that's going to be a little trickier. I think what I would have to do is say, for the asset index, do I want to... Let's take a look at this. For the asset index, do I actually want to draw the children of the asset index? And you can see that happening here, right? So you're saying for each of these, when we do the update and render, no, but that should still work too. I think I'm missing something here, because now that I look at it, you know, where it's drawing those pickables across the top, that looked actually fine. So here's the active group asset count, and it goes through there, and it's like set active asset on this editable asset thing here. So there's the dev ID. Why doesn't that work? Like, that's the dev ID, and it's the dev ID that's created right. Right here. I don't know, man. Probably gonna have to step into that, because I don't have a lot of ideas about whether we've broken it. It seems like this should produce the same one, right? Whatever the parent piece is here, and we're just passing the piece index here, so that should match right. And so when you're saying parent dev ID in here, that should tell me whether the thing's visible or not, right? And I'm not getting why that wouldn't be the case. So, like, all of those dev IDs are tracked, as far as I can tell, actually accurately. And so it should just be able to say, look, is that parent the one that you're focusing on right now? And if it is, I only do it if I should draw the children. So we're going to have to step in and see. I'll probably have to compile in debug mode. I'm not sure, because we're going to want to look at the actual code there pretty carefully. So if I select one of these, right, that should actually be switching to the actual dev ID. It's not just the asset. It actually knows which one it is. And then if I turn off the show children, that should actually have stopped showing that particular anyone who was attached to this parent. So the glove should remain, but the head should have disappeared, right? And I'm not seeing anything like that happen. It doesn't even register that those two things might be different. So if I go to, like, should draw children, just curious if that's ever even getting called here. So here's that. It's an inline call. Again with the disassembly. I'm not sure I'm going to learn much from this. All right, so if we switch to debug mode, inspect, let's see what's going on in here. So here's the should draw children call. We're stepping in here, and not really going to look at anything too carefully here, because we're not going to set up for it yet. But if we take a look at the editor, draw children is 1, as we would expect. The active asset index and the highlight ID, these are not set to anything, or shouldn't be right now, right? And they're not. So this will always be true. And so let's actually, real quick, just set ourselves up a situation where those things won't be true. So if I click on this and say, let me see the HHAs on it. I'm sorry, let me see the alignment points. I click on this and I turn off the show children part, like so. There we go. Let me just also make a point for this guy. Oops. So in this case, everything should be set up properly. And of course, we're not seeing anything happen. If I set a breakpoint and should draw children, what I want to do now is take a look at when we check this and what the highlight IDs are versus the IDs being passed down. So first things first, I guess, should draw children. I want to see draw children be false. It is, right? So that's good. And then what I want to do is say, all right, hit test editor highlight ID. What is that versus parent ID, right? Because we've got two separate things here. So looking through, one thing you can see that's actually kind of amusing here is, or I guess it's not amusing at all. So if you take a look at these two values, what you can see here is actually these two are set to the same thing. And these pieces here, and I guess the reason for that, well, I guess I'm not sure what the reason for that is. But these two things are set to the same value, whereas this part here is set to actually a pointer into I assume, I don't actually know what that's trying to tell me. But, oh, if those are the two separate U32 values that would break into. So this is set to something I'm not sure exactly what it is. But this is set to what looks like a pointer, right? So you can see the two values here. I mean, those look very pointer-y, right? So I'm assuming these are unions, right? So if you take a look at what these are pointing to, yeah, I don't really know. If we go back and see how they're created, so you've got this entity ID.value, right? And it looks like that's just the entity number. So these are both, we're asking about something that's in the same entity. Then the bitmap piece value, I'll be honest, not sure I understand how this dev ID from U32s is doing what it's doing. Because why would you have all this noise in there? The bitmap piece is just a single value, right? Like, that parent piece is just 0. So I'm not sure why dev ID from U32s is doing something so complicated as that. So I may just back up 1 second and remind myself how we were bundling these. So dev ID from U32s. Oh. Okay. So that right there is our culprit. We actually differentiate these by location in the code. And that's really all we need to know. That would do it. That's fine. I don't mind. What that essentially means is that that dev ID needs to kind of do this sort of thing. So what we want to do here is say, look, we know that we've got this dev ID. We want these to be harmonized types. So I'm just going to say copy the, have a thing that copies types So the same place that you would do dev ID from U32s, right? This same thing here. I would just say, look, I need to be able to copy a type like so. And then what it would do is this part here, that's got to be harmonized between the two. Because that was the differentiator for different types of these things. So the from value comes out there. It goes into the to value. And that should do it. I forgot that we differentiate these by where they come from. Right? And that's somewhat intentional. Like because we want to be able to stuff random garbage in there and have it actually work. So we want to be able to differentiate, you know, the number 0 and 1 are used as actual IDs in lots of places. We want to be able to use the file number to differentiate those two. But we want, oops. But sometimes we want to say, oh, I'm trying to refer to the same type as this other fellow up here. Make that happen, right? Okay, so I think that's probably all we were doing wrong, because I was like, we weren't doing anything fancy, so I was surprised that it wasn't working. That's why we actually have an additional layer of differentiation in there that I'd forgotten about. So if I go through here now and look at these alignment points, I'm thinking this will probably work better, or not. Let me double check that this guy actually is using alignment, which I don't actually know if they are or not. Add this in here. Well, that was anticlimactic. All right, so it's worse than that, I guess. So we're copying the type now, so those two things should be the same, right? That all looks reasonable. And then we're asking should have shown. Yeah, still don't know why that's busted. Let's try it one more time. So if I create the same scenario again, pick one of these, select this guy through here and say don't draw any children. Now I go back here and set a breakpoint. What am I looking at? So here's the parent ID. We've got this address of the string now. At least now we know what we're looking at there. And here's the actual value of the entity number and the piece index, right? We're looking at the highlighted ID here to say, is this the particular person who is being highlighted? And it is, right? So this should draw children. This is 0, and this should fail. So this should actually return false, right? Aren't those two things equal? There's a dot value 0. So those are equal, right? Exactly the same. A dot value 1, E dot value 1. Oops. Maybe I'm wrong. They are slightly different. So how is that possible, that those things could be off by a tiny amount like that? Yep. Wow. I am just totally out to lunch today. So don't ask me why I thought this change would persist out of here. It ain't gonna, right? You would need to do that. Slow morning, huh? We did great with our displacement code, and then it all kind of went off the rails. This should have taken like 10 seconds, and we totally screwed it up. But oh well. I'm going to say we finally got it this time, right? Let's just go hog wild. Let's compile release mode and just say it's going to work, right? I have a good feeling about this, says Han Solo. So anyway, take a look at here. There we go. That's all we really wanted, right? And so that's exactly right. Great. Okay, while we're on that subject, since we don't have a whole lot of time, right? I want to fix some of this nonsense that's going on here. So when we have the camera motion, it counts as a pick, and I want to turn that off, right? So I'd like to have the camera motion be something that's kind of like where it understands that the camera, when you're doing stuff with the camera, that you're not supposed to do stuff with the editor. It can be a hacky thing. I don't mind if it's hacky. It just has to not annoy me, right? And so in here, if we look at what's going on, you can see like the mouse up, mouse down, transition index crap. I think what I'd like to do here is say, look, just don't process this with the Alt keys down, because that means I'm using the camera, right? So what I might do here is say, okay, this transition stuff, let's just nerf it if the Alt's down. And that way the camera code can just do its own thing and we don't have to worry about it, right? Again, this is just improving the usability of it for my purposes. It doesn't have to be professional or anything. It just needs to be usable for me. And so like looking at something like this, what I want to do is be able to like go into the camera mode here. And now it's good, right? So now we're not having any of that spurious nonsense happen. We're staying locked into the edit that we wanted to do, right? All right, so that's a much better improvement too. Last thing is this stuff also sucks, and we've got the ability to use the F keys now. I think we should just use them, right? So, we could just make it so that, there's nothing, there's the camera stuff, there's the HHTs and that. And then this should just be alignment point edit, right? If I hit F5. So we should just like put that at the bottom of this and get rid of that one. And then this can just be its own thing, right? I think that's better, right? So let's try and make that happen. Again, and that's just getting rid of just some annoyances, things that are just making it more cumbersome to work with than it should be. I think we're almost out of time anyway, so this is a good time to just do a little bit of cleanup on that front. So if I look through here, this stuff is for section begin, right? You can see this section info, section bitmap editing. Yeah. So I think the section thing I just will get rid of, right? And then we'll just have a couple different ones of this. So maybe it would just do like HHA editor or something like, that. And everything that was going to go on in here, I'm just going to move out of there. So the section thing is not a thing, right? Like maybe that section should just be an experiment that goes away. So this can now just be eliminated. This will be the info part, and that can just go, I think, at the bottom. So I'm happy with that actually just going down here, right? It'll just append when whatever you're looking at, it'll just tell you. I think that's better. So that will go away, and then this can just be deleted as well, right? And I think that's all we would need. So then inside the asset editor, we just have to know that there's now an additional type, which is like the HHA edit part of things, as opposed to just the asset edit or not, right? And so that was, there was like a switch statement for that, where we were just saying like, what kind of thing are we editing in here? You can see it here. It's like, are we editing assets? Are we editing the camera? So I guess what I'd say here is like that. And then I just need to, you know, look at where that stuff is actually happening. So if I go to, yeah, it looks like that stuff is here for the debug state, and here for the rest of it. So that would probably be like camera, assets, something like that, I guess. So looking at how that's actually working, here's where the F key press stuff happens. So in here we just say like editing HHA, I guess. Almost done. All right. I think that gives us everything we need there. Excuse me. And this is just to make it so I don't have to fuss around with it so much. We can just get right into what we want. So that's nothing is F1. F2 gives us the camera information. F3 gives us whatever, you know, we're looking at here, right? We can get rid of these now. And then F4 was supposed to give us the HHA, but instead it switches to profile. That seems like a mistake. That's why. There we go. I think that's everything. The only thing I want to do is I want to get rid of that section picker. I don't like it, and it just gets in the way now, because now I can just do everything with the F keys, which is much better. So I don't really remember exactly where that was happening, but I suppose it's in here somewhere. Looks like there. So let's just get rid of that. So now I think we're just in a better place. That should pretty much give us something reasonable that we can work with quickly. Yeah. So here's our HHT stuff. Here's our asset edit. So, you know, we can now quickly get in there and pick everything that we want. Here's our camera, which we don't really need to, like, camera's pretty solid right now, so we don't really use that, but, you know, we might want to play with this again in the future, or add something more there. But that seems pretty good. Yeah. It feels like these probably should be only if you're in the asset editor. I mean, they don't need to be there for other things probably, but I don't know. I'll leave them for now. I guess that's it. So now we would really be back to just let's play with the art system a little bit and let's get this stuff together. So, you know, I would want to, first of all, take a minute to get the hero looking roughly correct, other than the fact that the head in the actual assets is wrong. But it should be pretty straightforward, right? So we know that we've got this part here. If I pick, for example, this, I need to add two things to it, right? I've got the one for the worlds, and you know, just looking at where that should be, I don't know, it probably would be like something like that. Just about like where it is standing in the world. I don't know. It's pretty hard. It's pretty close to 50-50 actually, where it probably is standing. And then where the head is, just looking at that, I'd say it's probably going to attach like, I don't know, right there would be where the base of neck is, right? I think that's about right. Looking at the headpiece now, that's really only got this part. We should get hats in here soon. There's some actually in the file there, right? Oops, that's to parent. And so, yeah, looking at where that should be aligned, it's probably something like that, I'm guessing, right? Seems about right. So then again, yeah, looking in here, if I go ahead and add one of these on here, I don't know where that should be exactly, but it's probably something like that. And then looking at where the head is attached, it's probably somewhere like there, right? Looking at this particular piece, again, this is going to have to be edited a little bit, but it's probably, because it's facing the wrong direction, should be facing leftward, but the art asset files have it flipped. But it's probably something like that, right? And so if I keep going through here, looking at that switch, you can see it's a little bit off, probably. So if I I'm not sure who is more correct. I'm not sure who is more correct there, but you can see it going a little bit off. Oops, that's the wrong one. So probably should be more like that. Seems pretty dialed. Let's take a look at this one. So that's not the right frame. Is it? Oh, it is. Yeah, never mind. Turn off that show children thing is very important. I'm glad we added that. So yeah, not sure where that should line up exactly, but something like that. So probably something like that. If I turn on the head point there, that's like, yeah, probably then something like that. Those green points are really far afield, though. Which is a little weird. Oh, I forgot I have undo. Keep thinking, hey, this is a tool we made ourselves. It probably doesn't have undo. It does. So I'm guessing it's more like that. That looks about right. And let's take a look at this guy. I think that's about right. This one is base of neck. And it's probably something like that, right? All right. So now I want this to just have a to-parent on there. So I don't know where that would attach exactly, but yeah, probably somewhere like there. And then for here, yeah, like more like that would be where the neck would be, I guess. And here, and so I think that's all the alignment for that is now correct. So if I ask it to save that, hopefully that's right now. You know, again, bunch of work. So now we want to see, you know, does this actually work? I have no idea if it does. So if I load it now, are all those remembered? And they are. All right, so that's good. We're getting there. So that's pretty good. You can see it looks like we're getting a little bit of an interpenetration there, so we may have to take a look at that alignment for when, like, that that shearing, because we're using a fixed distance, like I was saying before, that interpenetration for the shearing may be a problem, so we probably want to look at that as we go. But otherwise, yeah, looking pretty good, right? We can put heads on some of these fellas too now. I don't know why I can't. Is there a reason I'm not seeing an alignment point there? Oh, right, because it only shows up in debug. Let's look a little bit more like that. All right, so the cat probably sits on its base, something like that. You know, it's going to be on its haunches, sort of, right? Like this sort of thing. The base of neck is going to be like there. It's got a really pronounced location for that, so that's pretty easy. Let's go back to show children. Let's get the cat head on there. So that's going to be like there-ish, right? And off we go. So our cat has a nice little setup now. I don't know what this dude is doing. I can't remember his name. It's like Laird, I think. Although the bodies are generic now, we don't actually... This is the body that originally went with Laird, I think. But we don't actually... we're letting heads and bodies be freely interchangeable now, so it doesn't actually matter whose body this was originally. So there's the base of neck, and that's not Laird. So, case in point. Let's get that set up properly. I'm going to turn off show children. All right, there's our base of neck there back again. Let's figure out where that head goes. Add that there, and put that to basically the right place. Probably should keep it at this camera angle when we're doing this. Looking here, yeah, that's in the right place. This is not quite, so it should be more like that. And I think that's right now. So you can see how much distance there is movement there, and it looks like it's too much. Like it gets a little too displaced from the body in that case. Now we could, there's a couple different ways we could look at that, but I think that just means that there's too much displacement as far as the orphans are concerned with how much off of the body they are, right? And the player, I guess in this case, same thing, right? Maybe I went a little bit too overboard on that, because you can kind of see, for the head, that's the case. Now, part of that might just be because the heads are too small on these, right? Like, that head looks too small compared to like the size of the player head. So it could be that we want those heads to be bigger, or maybe the bodies need to be bigger as well, right? Like, it's hard to say. But again, that's the kind of thing that we can tweak with now, and we got to kind of decide. But like, you can imagine if we made that head bigger, right? It might be different. Or if the attachment point was placed a little bit differently, right? Like if it's more like that. So, yeah, let me just see what ends up happening there. Yeah, the displacement looks like it's going to be a little bit too much. So I think that's probably something we'll have to get into next time. And I think what I'll probably do next time, but it's getting really good. I mean, it's getting pretty close to right. But that displacement's just a little too pronounced. So I'll have to tone it down just a little bit. Just give it a little less Z delta, right? And then I think we're fine. All right. Q&A. Zero LPBM says, shouldn't body pieces displacement be a function of camera distance and maybe angle? Distance, no. Angle, yes, and it is currently a function of the angle. That's actually exactly how we implemented it, right? But I'm not sure why the distance of the camera would change how you want to displace it. There's really no reason why the farness of the camera should change the way we want to displace it, right? We can't really do the gloves yet because we need to actually put in code for how the gloves are going to float, right? And so we kind of want to do that as a separate thing. You know what I'm saying? We do want to do hats because there actually are some hats in there right now. And so we should add hats as another thing to test the alignment stuff, right? But again, that's kind of more of something for a different day. Maybe turn down lighting quality debug must be remove SPS skin. I think what we're actually going to do is just fix the lighting sometime soon. What graphics APIs does Handmade Hero use? Right now, it just uses OpenGL. It's the only one it uses right now. And that was done because that was like the most cross-platform thing I could use at the time. So I thought it would help people be able to, like there's people who try to follow along on like Mac and Linux and stuff. And it was, you know, the easiest thing for, I think, everyone to be able to use a little bit of at least. No, I think this is what the final lighting will look like, roughly. I think it'll just be faster, right? Because it looks like what I want, right? You know, that is roughly what I want. The only thing we're not doing right now is we don't like the sprites. And when I do the improved lighting pass, we will light the sprites with the same lights we're lighting, the same lighting we're using for the world. I'll probably be able to take some more of the flicker out of it too, in the final pass, like hopefully. But other than that, no, that's what it looks like. I, German Troy, I followed 15 of your videos and now I'm in a game dev studio. That's pretty quick. Which 15? Nice work. Have you tried out Vulkan on any project yet? Not. I just don't think it's useful, so I have not put any more time to it other than when I initially looked at it to determine that it wasn't good. So I probably will never look at it again, I'm guessing. Because, like I said, I don't see it having a reason to exist at the immediate moment. Well, because of the flickering in the lighting, well, it's because we can't sample all of the rays, so we basically have to just sample a subset of how the lighting is being translated around. And so that subset that we're picking changes every frame, and that's what leads to the flickering. The skewing when moving on Y is only applied to the body. Should the head also be modified? I don't know. Again, that's sort of something we can play with like a little later on down the road when we're doing some more work with animation sorts of things. For right now, it seems fine to me as it is. I would like the head to be bobbing, which it's not at the moment, so we probably add that, but yeah. Is the light estimated using Monte Carlo integration? Yes, in a sense. It's using a kind of a couple different things. It's based on randomized sampling, but it's highly stratified. Like, so it's not really Monte Carlo in the pure sense of the word. I mean, anything that does randomized sampling is kind of in the Monte Carlo camp, but we're fairly regularized there. And the other thing is we also smooth over time. So we're also kind of not just a straight, you could write a straight Monte Carlo lighting thing that didn't do any of those things. So we don't do that. But we are fundamentally doing that, yes. Is there a good article on camera in the computer graphics field or video games? I'm ready to learn in detail about the camera. There might be. You're looking for this sort of stuff, right? This This is not particularly introductory. So I guess there's gonna be. I would chase around references in here. Mitchell Hanrahan. Oh, Don Mitchell, in fact, who is a friend of mine. He's the guy who taught me ray tracing, actually. I mean, advanced ray tracing. Let's look at what he had to say. And Pat Hanrahan, obviously, I mean, everyone knows who Pat Hanrahan is. Or I hope you know who Pat Hanrahan is. So this is a nice old one. Realistic camera model for computer graphics. This is looking good. This is looking good. This might be a good place to start. They got a lot of stuff in here, right? So here you can see them talking about like how the lens aperture, how the light's going through it, right, and what it's doing. And that's really what we want to know, right? The thin lens approximation is like kind of the old school way, right? The thick lens approximation, well, thin lens is still better than pinhole camera, but thick lens approximation is like talking about lenses that actually have some light behavior inside them. And so this might be a good place to start. I don't know. I can only skim it from here, but this might be a good place to start. I also don't know if like for some reason I thought this book was like made available for free somewhere recently. Maybe I'm wrong about that. This is what I'm talking about. You could try this. Here we go. Here's the thin lens model. Do they get to thick lens? I don't know if they get to thick. Here we go. So this might be another place you could try. Right here. pbrbook.org 3ed-2018/cameramodels.html. Camera_models.html. Your mileage may vary, depends on who you like to read, right? I find this book isn't written, it's in that like literate programming style where the code and the book are together. I find it really not great. But it does have like all the information kind of collected in one place. So I find it a little hard to read, but if you can get past that nonsense, that might be something to think about, right? I don't know if that helps. Regarding Vulkan, I wonder why you don't think it's relevant. Well, I think I've said this like a billion times, though. It's not relevant because nobody's platform's making it their priority rendering system, other than Android, right? Games are shipped on PC primarily, and that's D3D12 or D3D11. That's what Microsoft pushes. They don't push Vulkan, right? So that's the platform renderer there. Mac has said nobody gets to do anything. It's all metal, right? Like everything's on top of metal and forget the rest of you, right? So they're not putting resources into Vulkan. People just have to make Vulkan work on Mac as best they can, right? Just like OpenGL or something. So it's metal is the thing that Apple said is what we're doing, right? PlayStation 4, not Vulkan at all. Has nothing to do with Vulkan, right? It's the AMD. It's sort of more. I mean, it's vaguely related in the fact that it's like the AMD style stuff, but it's the custom PS4 one. The Xbox One, definitely not, right? That's D3D12 style. And then I guess you're left with Nintendo Switch. I don't know what people tend to use on that, but they have their own API, obviously. So it's just like really for the types of games we talk about, it's PS4, Xbox One, maybe Nintendo Switch, maybe not, depending on how high a horsepower you're shooting. And then PC and Mac. Vulkan is like nowhere to be found. It's a secondary, like on top of compatibility layer kind of thing at best. So I have no idea why you would use it, right? You're not going to ship that native on iOS or Mac. You're going to ship a metal driver version. And so why would your second driver version be Vulkan when it could just be D3D12 and you'd be on Microsoft's native path, right? I mean, it doesn't make any sense. So I really don't see Vulkan serves like no purpose. I don't know what you would use it for. It's just clogging up the works, right? If vendors decided that they're going to get together and that's the primary API that you're going to use on these platforms is going to be Vulkan, great. But that's not what happened. The OS vendors decided that their APIs are the ones that are going to get used. So that's what happened. If in the future people discard those and they say we're not going to use metal anymore, we're going to switch to Vulkan, then it makes sense, right? But that's just not. Nobody did that, right? Are you going to compose specific particle effects to the editor? I don't know. We could put parameters for particles in there. We haven't played with particles much other than to make sure that we could do them. So we probably do have to do that at some point, right? Whether or not we bother making any editable things in there, I'm not sure, but we might. All right, we all done? Are we all done here? I think we're all done here. Nintendo Switch is kind of pushing Vulkan, isn't it? Which is, I guess, kind of similar to mobile programming. Yeah, I don't know what they're going to do with that. Like I said, it's entirely possible that in the future, people could decide to switch to it. If, like, Microsoft decided they don't want to maintain a separate API anymore and they switch to it or something, right? Then it becomes a compelling use case. At the moment, I just don't see the point. What you're doing with the graphics API is you're trying to minimize the amount of compatibility headaches that you have. And really the only way to minimize the compatibility headaches that you have is to use the OS vendor's preferred API. Like you just don't really have another choice. Um, and so it's fine to use something like OpenGL or Vulkan for experimentation or development purposes, or even on Handmade Hero, we could have decided to use it because it's an educational stream. But when you're actually talking about what do you need to do to ship the game, you absolutely don't want to use a different API. Shipping a game on OpenGL is like fraught with peril. You really want to not do that, right? You want to ship it on D3D and Metal. And the same will be true of Vulkan, I 100% guarantee you. You can do it, it's just you're creating a huge amount of extra work for yourself for no real reason, right? And so that's what I would say. Now, if in the future, like I said, if people maybe get on board with it, and so people say, oh, okay, we're gonna like support this API as our platform native API, that would be great. I wish Vulkan were a better API so we could standardize on one that wasn't crappy, but like, hey, at least at that point, it's fine. Because you know that the compatibility headaches will go away, right? That's my opinion on it anyway. What did Insubot say? Struct name member name equals. Yeah, that's a good point. That's a very, very good point. Yeah, I would see. So, looking ahead to the future too, I would say that the most likely scenario might actually be if Microsoft were to adopt Vulkan. They've kind of been like more into the open sourceness sort of things lately, you know. Um, so amusingly, they may actually. I could see them doing it before, um, uh, before Apple these days, which is kind of funny because it used to be the other way around, right? But I could see them doing that, saying like, why are we maintaining this separate API like when we're kind of open sourcey these days? And so that could happen. I don't know. Um, Mac, like Apple, seems really dedicated to doing their own thing, so I don't know what's going to happen there. I really don't. Um, it's a mystery. What I can tell you is it sucks that we have so many APIs now. We've got OpenGL, Vulkan, Metal, D3D, custom ones on the platforms and stuff, right? So yeah, it's dicey. Does OS support really matter that much? Seems like it's really GPU driver vendors who have to correct. Yeah, OS support matters tremendously. It matters tremendously. The problem is that the operating system plays a huge role in how those systems interact with everything, whether it's like, you know, even things as basic as whether Alt Tab is working properly, right? Um, and so you really just don't want a position where the OS vendor doesn't care about Vulkan. They care about their own API, and so like multi-monitor doesn't suddenly work properly with Vulkan, right? Or, you know, all these other sorts of things, right? And so you really want the OS vendor to care about the graphics API that you choose to use. You really want that to be true. Um, and you know, I don't have a crystal ball, so I just don't know what's going to happen. Hasn't this have to use the platform specific API thing always been the case for multi-platform console games? Yeah, I mean it's nothing new for game development, right? It's nothing new. I'm just saying that's why I just don't get the point, you know. But that could change, and then it would become a more interesting API to put time into, right? As soon as a major platform vendor actually said this is going to be our API now, and maybe Microsoft could do that, then it becomes possible. It'll still suck, but at least there's a reason to use the thing that sucks instead of just because, well, I don't know why. Right? Linux people care a lot about Vulkan, if that means anything. It doesn't, because Linux, like, no one plays games on Linux. Or I should say no one buys games on Linux. And they always say they do, right? But then when you ship a Linux version of your game, literally nobody buys it. So there just isn't a reason to care. Like, Linux could be on anything. Linux could be on any API they wanted. It would not affect games at all, right? Which is unfortunate. And it has not made a dent. Like, literally nobody has ever been like, oh wow, that shipping the Linux version of our game actually paid enough money to be worth the porting cost. Never happened, right? People say it over and over and over again. Every game studio that ever does that, they're like, wasn't worth it. So that's just the way it is. And again, that too could change at any time, but it just hasn't. So there you go. And yeah, like, people are saying even macOS isn't worth it. It's totally true. macOS is rarely worth it too. macOS is less of a concern though, because iOS is often worth it for you depending on what you're doing. And so porting to Metal makes some sense because you have to do that for iOS anyway. So it's it's kind of a different thing, but all right, I'm gonna close it up. All right. Thanks everyone for joining me for Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along the series at home, you can always pre-order the game at handmadehero.org. And it comes with a source code. So you can port it to Vulkan if you want to. Actually, I think some people have already. That's about it for today. We accomplished basically what we want to. It looks like the idea of using a fixed distance isn't quite right, because when we do that skew, you can see that we were still interpenetrating to the ground there. So I don't know exactly what we're going to do to fix that problem. We may have to still use an adaptive motion, which has some issues for rotation, and I'm not sure exactly what we should take away from that. But we'll take a look at it. But mostly we're pretty much out of the woods on that because we're getting some pretty nice sorting in there now. It's really only for those skew vectors that we're really having a problem. So next week we won't do a Handmade Hero. We're doing a 4-coder jam next week to finish up the 4-coder mods. So hopefully you'll stop by for that. That's not really a stream. That's just kind of like an all-day thing that people come and go for. So if you're interested in that, that'll be happening next weekend. And then after that, we come back the weekend after. That's when we'll be doing probably some just looking through, like, okay, how do we finish getting items in to the asset processor, put some sound input in there, since now we have a good place to list them, that sort of stuff. So we kind of just want to go through and make a list of sort of where we're going now, because we're getting pretty close to everything being done. Just got to take a look at what's not in there, right? And at some point, we've got to decide to spend another few weeks on lighting to get that really straightened out and hammered out. So that's it. We'll be back for some pathfinding 2 weeks from now. Pathfinding for the project, not pathfinding like AI. And hope to see some of you for a 4-coder jam this coming weekend. Should be fun. Until then, have fun programming. I'll see everyone on the internet. Take it easy, everybody.